Welcome to this 11th video of Similarity lesson number 1st from Standard 10 Mathematics Part 2. In our previous video, we have seen sums to be solved on the similarity of triangles. Now we are going to see the next sums from the practice set 1.3. Previous video we have seen first 3 sums. Now let's see the fourth sum from practice set 1.3. Okay. Now in this figure it's given that in this triangle ABC, AP is given perpendicular to side BC and BQ is given perpendicular to side AC. P is somewhere between B and C and Q is between A and C. And now we have to prove that triangle CPA similar to triangle CQB. And if AP, BQ, AC are given its length and we have to find length AC. So here in this question there are two parts. First we have to prove these two triangles congruent, and when we prove these triangles congruent we have to find the length AC. Okay, now let's see where is the triangle CPA. Point C is here, P and A. So this is the triangle required, CPA. So we will have this rough work first. First we have to take triangle CPA. Okay, and here the another triangle is CQB. C, Q and B. This is the triangle CQB. Okay. Now let's see in how can we prove these two triangles similar. Now we know we have 3 different tests of similarity. AAA or at least AA test. Second is SAS and the third is SSS. These are the 3 tests available for us to prove any two triangles. Now to prove these two triangles similar, we cannot use these sides. Because after proving, if it is given, then we have to find. So at present we do not know lengths of these sides. So wherever the side come, we cannot use that test. So this test has gone. So we have to use only this AA test. Okay. So we have to find which two angles of this triangle we can prove congruent with this triangle. Let me tell you one smart tip or general thing that in question, generally when these names of the triangles are given, they are generally in the correspondence. 99% they are in correspondence. So we can think, can we show angle C is congruent with angle C? Now for triangle CPA, this is the angle C. And for CQB, again this is the angle C. So it is not only name is same, but the angle is also common. So we can show that angle C is congruent with angle C because it is a common angle. So we got one pair of corresponding angles in both. Now let's check, can we show an angle P is congruent to angle Q? Okay, can we show? So where is the triangle P? CPA, this is P. Oh, this is right angle. And in CQB, Q is also right angle. So we can show angle P is congruent to angle Q because both are right angle. Once we get 2 pairs of corresponding angles congruent, it's very easy to prove these two triangles similar by AA test. So we can prove this. So let's write this proof now using this rough work part. Okay. So how we will start our answer? We start our answer that in triangle, write the name of the triangle in the same sequence, CPA and triangle CQB. Okay. So this is the rough part, students. Now the first statement we will write, angle C is congruent to angle C. So when writing this angle C congruent to C, write this vertex of the angle C in the middle position, leaving some space over here. C is congruent to angle C. Okay, we will write that reason afterwards here. Now when we have written this vertex C, how to write this angle C using 3 letters. Now if you will see the figure, you might get confused. A simple tip is to write this angle C using 3 letters. Here we have taken this C. Now the remaining 2 letters from this angle triangle CPA is P and A. So right here the remaining 2 vertices, one to the left of the C and one to the right of the C. So we have written angle PCA. It means angle C only. It is congruent to angle. Now we have taken here C. So which 2 letters are remaining here? It is Q and B. So this angle is nothing but your angle C is congruent to C. Let me write this, then I will rub this part and I will show that the reason also how to write in the bracket. Now another triangle is angle we are going to show. Angle P is congruent to Q. So write this P congruent to angle Q like this, having some space to the left and right of the letter. Now from this CPA triangle we have taken P here. So what are the two letters remaining here? C and A. Write it like this, one to the left and one to the right. Here we have taken Q, so remaining is C and B. C and B. So here we are writing P angle and Q angle are congruent. Now let me rub this rough work part. Okay. And now let me show you how to write this reason. So why these two angles are congruent? Here the reason is common angle. This is the reason. And here the reason is each 90 degree. Each 90 degree. So with this reason, these two angles are congruent in these two triangles, and therefore triangle CPA is similar to triangle CQB, and by which test? It is a test. Okay, when we are proving similar, it's test of similarity. Okay, now if this is test, now let's see how to find AC. Now AP, BQ, BC and AC, this thing we have to find. Now we will write the corresponding sides of these two triangles which are in proportion. Now we want, which side we want? Do we want CP? Search here, CP. Do we want CP? No. Now CP upon CQ. Neither we want CP nor we want CQ here. It is neither given information or we have to find, so skip that. So first two letters, skip it. Now take the another two letters, second and third, PA upon QR. Do we want PA? Yes, we have PA here. And do we want QR? QR. Okay, where is QR? This is QR. Let's check what is given to us. AP is given 7. AP. AP is, okay, let's do some rough work column. In triangle CPA, the three sides are CP, PA and CA. Now which we know? Let's see. CP not given. PA is AP. It is 7. CA is AC, that we have to find. We can take it as X. Now the another triangle is CQB. CQB. Here it is CQ is one side, another is QB, and the third is CB or BC. Okay. CQ, that is QC, not given. It is not given to us. QB is BQ. It is 8. Okay. And CB, that is BC is 12. Okay. So we know about these two sides. One side we know, we have to find another. Here we know both. So skipping this first pair of corresponding sides, let's skip it. Let's write this PA upon, oh, here it is, should be QB, not QR. So that's why it was a confusion. So let it be. So PA upon QB is equal to CA upon CB. So when we want to write the corresponding sides, it's very easy. Take first two letters, divide it by first two letters. Okay. Take second and third, divide it by second and third. Take first and third, divide it by first and third. You will get the corresponding sides. So we have written this. We can write corresponding sides of similar triangle. This is the abbreviation of corresponding sides of similar triangle, CSST. Now substitute these values. PA, it is 7. QB is here. 7 upon QB is 8. CA, that is AC, we have to find. We can make it as AC only, or we can put it as X. And BC, that is CB, it is 12. Okay, so we have substituted these values. From this we can get AC is equal to cross multiply 7 into 12 and you divide this pair with AC, it is 8. So if you do the calculation of this, you can find the value of AC. So 4 2s are 8, 4 3s are 12. Okay, so 7 3s are 21 upon 2. Either you can write 21 upon 2 or you can make it 10.5. So this is the length of AC. So here we have proved this triangle is similar. This is the one part we have done. And the second part we have found the length of AC. So this is the answer of question number 4. Okay. Now let's go for solving question number 5. Now in question number 5, it's given that in trapezium PQRS. So this is a trapezium PQRS. PQ is parallel to SR. You can see this PQ is parallel to SR. And AR is 5 times AP. Where is AR? This is AR. This is 5 times AP. Okay. AS is 5 times AQ. AS is equal to 5 times AQ. Okay. So suppose it is X. This is 5 times X. And if AQ is say Y, this is going to be 5 times Y. And you have to prove that SR, this is SR, is 5 times PQ. Means if it is Z, then we have to prove it is 5Z. This we have to do 5 times. Okay. So how can we prove this 5 times? So if you observe this figure where we have two triangles, this is a triangle APQ and ASR, where the lengths are X, Y, and supposingly this is Z, and here we have 5X, 5Y, and we have to prove it is 5Z. This is to prove. Means whatever the sides of this triangle ASR, we have to prove it is 5 times. Two sides are given 5 times of two sides of this triangle APQ, and we have to prove the third one is 5 times of the remaining third side of this triangle. When it is possible? When these two triangles are similar. If we can show similar, then the corresponding sides will be having in same proportion. So how can we prove that these two triangles are similar? Now, again we can choose by AA test or SAS test. Okay. Now here, so using AA test is the very much easy part. So try to, if you can show by AA test. Okay. So if these two triangle sides are parallel, now if you take this as a transversal, PR is transversal of PQ and SR, you can prove that angle P is congruent to angle R because these two are alternate angles. And what about angle Q? If you take QS as a transversal, then you can prove angle Q is congruent to angle S because this is also alternate. And if you want, you can show that angle A is congruent to angle A because it is vertically opposite angles. So here we can show all three angles of these two triangles, corresponding angles are congruent. So we can use any two, whichever we want. This pair alternate angle, this pair alternate, and this pair is congruent because of vertically opposite. Okay. Let's select these two with having same reason, alternate angles, and let's prove that two triangles are similar. Okay, now when we write the name of the triangle, we should write in proper correspondence. So when we start this answer, okay, now in triangle, first triangle we can write as we want. Suppose we are writing say APQ. Okay, so if I written APQ first and triangle, for this second triangle, bigger triangle, corresponding to A angle is A. So here first letter A, here should be first letter A. What is the corresponding angle to P? For P, here the corresponding angle is R. So it will be R. And which is the corresponding angle for Q angle? It is S. A-R-S. So in these two triangles, what we can show? So angle P is congruent to angle R. Okay. See the way I am writing P and R. These are alternate angles we have written. So P and R written with the space, and now we write the remaining letters A, Q here, A and S here. Okay. And now reason, one more angle we will write, and we will write that reason together. Angle Q is congruent to angle S. And Q we have taken here. So remaining is AP, AR. Okay, so these both the angles are congruent because they are alternate angles. Reason is same, that's why I have selected these two angles. Otherwise we can select angle A also as vertically opposite. Fine. Now with the two angles we can say triangle APQ is similar to triangle ARS by AA test. Okay, now we will have this, all three sides will be in proportion, correct? Therefore, how we will get the proportion? Select the first second. AP upon, this is AR, is equal to PQ upon RS, second and third. And now take the first and third, AQ upon AS. This is the reason corresponding sides of similar triangle, CSST. Now put whichever you know. AR is 5 times AP. So AR is here 5 times AP. So AP will be as it is 5 times AP is equal to PQ upon QR. That we do not know. We have to prove it. So it is PQ upon RS as it is. Now AQ, 5 times AQ is equal to AS. So AQ will be as it is upon AS. AS is 5 times AQ. You can write given. From given, we have substituted these values. Correct? Okay, let me wrap this part of this answer. So we can continue here. Okay. Now from here, let's start here now. Therefore, AP will get cancelled with this AP. Therefore, 1 upon 5 is equal to PQ upon RS is equal to, here also AQ can get cancelled and it will be 1 upon 5. And therefore, all these ratios are same. And therefore, you can say that, therefore, PQ into 1, PQ into 5 is equal to 1 into RS. That means 5 times PQ is equal to RS. This we have got. Now what you have to prove? SR is equal to 5 times PQ. Just write this RS on this side as SR is equal to 5 times PQ. So this is the same statement, only we have written the right side to the left and left to the right. Is proved. So in this way, we have proved these two sums. Question number 4 and 5 from your practice set 1.3. In the next video, we will see the next sums. Thank you. If you have understood this concept properly, please give me the likes, share it, and give your comments. Your comments are very valuable for me. And if you are not yet subscribed to the channel, please subscribe. Thank you.